Let's start the new concept, algebraic identities. Few of these algebraic identities you are already aware about and few you are going to learn first time. This is the idea behind the factorization with the identities. So first of all, let's start with these two identities. In grade 8, you learn about a plus b whole square, a plus a minus b whole square as well, and these two identity as well. This we are going to learn again this year, and in addition few as well. Let's start. First of all, it is x plus a into x plus b is equal to x square plus a plus b into x plus ab. This is actually middle term splitting, right? Now, see over here that x is being repeated, x and x. So first number will be same. Second number could be anything in both of them. But first number or first term should be same in both of the bracket. Then you need to do square of the first term plus addition of two numbers into first term plus product of the remaining two numbers. We are going to do few questions based on this, right? And the second is x minus y into x plus y is equal to x square minus y square. This you learn in grade 8, very simple it is, right? Let's start with the examples of the first this identity. So let's take an example, x plus 8 into x minus 10. Now x is same, see over here x and x, then so we can directly write x square over here. Then let's write plus addition, let's say this is a and this is b, so addition of them, let's write in bracket 8 and here minus 10. Keep in mind, if there is any negative sign anywhere, you are supposed to keep it there, right? So if negative sign is there, please keep it there. If positive, then no need to bother about it because positive is already there, but negative is the unique thing over here. And finally, we are supposed to multiply those two numbers. So 8 and here minus 10. Done? So here it is x square, here 8 minus 10, that's minus 2x. And finally here 8 tens are 80 and minus is there. So minus 80 it is. So this is how we find the product. First we are going to find the product, right? So this is about the product of the two binomials, right? Now let's do one more question here, that is 3x plus 4, 3x plus 4 and another is 3x minus 5. Now this is very interesting question. Previously we had only x and in the identity as well we have x, right? So in this case, are we going to write x square? No, we are not going to write x square. We cannot write x square. We are supposed to write this term and square of it. Be careful, right? Second term we know very well, right? Subtraction or addition of these terms. So here 4 and minus 5. Now see, in the identity again one more time x is there, but in our case what is x? We are supposed to replace or with 3x, so 3x. Then finally product of these two, that is 4 multiplied by minus 5. So let's simplify it. Here 3 square is 9, x square is x square. Here 4 minus 5, that is 1, minus 1 only, and 3 over here. So minus 3x. And finally 4 5s are 20 and negative sign is there. So minus 20, right? Very simple to do, but you need to keep in mind that value of x. If it is x, it is way simpler. Need to just change few numbers into the identity and we can get the answer. Very easy. But when you don't have only x but you have some coefficient other than 1, then you need to be very careful. If it is y over here, we replace x with the y. Depends on the variable. Now let's discuss the application of this identity. We are talking about this identity still. We'll discuss about the second as well. We are still talking about the first identity and its application in the multiplication of numbers. Let's start with the very first question. So let's start. Let's take 102 multiply by 105. Suppose if you want to multiply these two numbers. Then how will you do that? 102 multiplied by 105, and you are not supposed to multiply it. Let's say we don't know multiplication proper, but we know identity. Yes, we are smart, right? So let's apply the identity over here. So how will you do that? I want to use the first identity. Instead of 102, I can write 100 plus 2 multiply by 100 plus 5. This is what I can write it. Now, the reason behind taking 100 is to have the first number or first term as similar, like this case, x and x. And second number can be different. So here, let's write 100 square. You must be thinking why 100 square? Because first is what? It is x square. Then plus, let's write plus over here, addition of the two numbers, that is 2 plus 5. And x again, in our case x is what? 100 plus AB, which is product of two numbers. So 2 into 5, right? Done. Now let's solve it. Here 2 extra 0 will be there. Here 5 plus 2, that is 7 into 100, that will be 700, and plus here 10. So if we add it, we are going to get 10,710. Very simple. We did not multiply in the normal way. We did not get the very long answer as well, right? We apply the identity. Remember 102 and 105. The sign between this to use this identity is to see that both numbers are more than 100. Both of them are, right? And it is near to 100 as well, right? 102 and 105, they are near to 100, right? So 100 and 100, we start from 100 plus 2 and 100 plus 5 as well. Now apply the identity and you need to solve it. Now let's discuss one more question here. Now let's take here, that is 98 multiplied by 99. So let's do this one. Now here you can do one thing, that 90 plus 8 and 90 plus 9, that is also possible. But remember, if you take 90, again you need to find the, I think, product of 8 and 9 again, then square of 90 as well. But if you take 100, there will be very less headache to do the calculation. So what I will be doing over here, that is 100 minus 2 multiply by 100 minus 1. Again, I want to find, or I want to have the first term as the common. That's what my idea is. Now if you subtract 2 from the 100, you get 98. Good. Now if you subtract 1 from the 100, you get 99 as well. Simple, right? So this is the same case that we discussed in the first identity. Now let's solve it. First we need to have 100 square. So here we will have 100 square plus it is minus 2 minus 1 and x. If you see in the identity, that is in our case 100 plus we need to have the product of two numbers, that is minus 2 and minus 1. So 100 square is, we will be writing what? 10,000. Here minus 2 and minus 1 will make minus 3 multiplied by 100. So that's minus 300. Minus 2 and minus 1 positive. So plus 2. So 10,000 minus 300, that is 9,700 plus 2. So answer is 9,702. Simple. We get the answer without actually multiplying these two numbers and these two as well. Remember, this is the middle term splitting identity only, but we did reverse in the factorization. Here, this case is about finding the product, right? So let's recall one time. So you have the first term as the common, right? You can see in this example 3x and 3x. You can do with the numbers as well. Then add another number. Maybe you have positive or negative, but if it is negative, do not forget to take sign along with that number, like we have taken in this case and in this case, and I believe in this case as well, both of the numbers here, because both of them are negative. Then you need to apply the identity. Put your numbers properly, simplify in the correct way and get the answer. Now let's discuss the second identity. Let's discuss the sums related to second identity. So let's start. Here we have 4 minus 5x and 4 plus 5x. If you remember the identity, it was of this form: x minus y and x plus y is equal to x square minus y square. We just need to do the individual square and subtract them. That's very simple. So let's do here 4 square minus 5x whole square. So 4 square is 16 minus 25 and here x square. So that's the answer. Very simple to do. You just need to take the square. Let's discuss one more question. Here let's take y square plus 3 by 2 and here y square minus 3 by 2. So how we shall do this question? So here again we are going to follow the same x plus y and x minus y in this form. So y square whole square minus 3 by 2 whole square. So here y square and square. So when we have double power, we learn in this chapter number 1, we are supposed to multiply. So y raised to 4 minus square of 3 is 9 and square of 2 is 4. Very simple to do, right? Let's discuss the application problem of this one in the form of multiplication of the number. So first of all, let's take 105 multiply by 95. That's the first question. So 105 multiply by 95. So how shall we do it? Previously, the condition was that only first number should be similar. But here, what do we want? Both numbers should be similar, and one time it should be subtraction, another time it should be addition. That's what we want. So let's start here. So 100 plus 5. Now if I write the another bracket, it should be same numbers but with the subtraction. So obviously I will be getting 95. 100 minus 5, right? 100 plus 5 and 100 minus 5. Very simple. Now what's the answer of that one? That is x square minus y square form. Square of the first number minus square of the second number. So here we can write 100 square minus 5 square. So square of 100 is 10,000 minus square of 5 is 25. So now if we subtract, we are going to get 9,975, right? We got the multiplication just by doing addition and subtraction, kind of square as well. This is the way to do it. Now let's discuss one more question. So let's take in this case 102 multiply by 98. You can give it a try. That's very simple to do. Very easy identity it is. So let's write here 102 can be written 100 plus 2 and here 100 minus 2 will give you 98 and 100 plus 2 will give you 102. Simple. So one time addition, one time subtraction, and we have the same numbers. So we can write 100 square minus 2 square. So 100 square, like we saw, it's 10,000 minus here 4. So answer will be 9,996. Just we need to subtract the 4. So this is how we do the application of this identity, the second identity, and the normal problem. Remember, these are the problems related to finding the products. The reverse of this will be the factorization. Now let's discuss the other identities. Now let's do the factorization with the few identities that we know so far. So let's start with this one. First of all, 4x square plus 4xy plus y square. Now this is the identity that we discussed in grade 8. So it is of this form. If you remember, a plus b whole square is equal to a square plus 2ab plus b square. And if you take minus here between them, a minus b whole square, that is a square minus 2ab plus b square. So these are the two identities, right? Now if you compare this one with this, what we should have, first of all, the most important part, we should be having at least two perfect squares. Two perfect square. 4x square, yes, it is a perfect square. Y square, it is a perfect square, right? Remember, perfect square is the only way to identify that we can apply this identity or not. So here we can write square root of this, square root of 4 is 2, and of x square is x, and 2 as the power, because we are talking about the square. And here y square will be y square only, and plus. Now about the middle term, 2 should be there, so let's write 2. And first term, a means first term, so here it is 2x, and the second term, that's y. So a square plus 2ab plus b square, it is of this form, simple. So what we can write, a plus b whole square. A in our case is 2x, then plus, and b is y, so whole square. So this is how we solve this as the factorization. Now if you want to write in expanded form, that's 2x plus y into 2x plus y. So these are the two factors of this first question. Remember, the most important part is to have two perfect square. This is the idea, that this is the identification that's going to tell you we can use this identity. Start with the first term, last term, 2 as it is, it should be there, middle term, then multiplication of those terms. If the terms are matching, we can use this identity. Let's discuss another question which is over here. So 16x square minus 8x plus 1. Again, in this case, if you see three terms, try to find the two perfect squares. Let's see, 16 is a perfect square, x square already is there. Now 1 is also a perfect square, because square of 1 is what? 1 only. So here we can write that, let's see, square root of 16 is 4, and of x square it is x, and here square. Here I can write 1 square, because square of 1 is 1 only, right? So that being done, a square and b square is done. Now about the minus and the middle term. Middle term here 2 is there. So first of all, let's write 2 here, then b. A is what? 4x, and b is what? 1 here. So what we can write, a minus b whole square. So here let's write a is 4x, then minus, and b is what? 1, and here square. Let's write further, which is 4x minus 1, and here also 4x minus 1. Very simple to do, right? We have three terms, out of them two are perfect square. So this is the idea that we are supposed to do this identity. Now let's discuss one more question which is having only two terms and both of them are perfect square. Okay, we discussed this about already. So it was like this, x minus y into x plus y is equal to x square minus y square. It was of this type. This is what we discussed about. Now we are going to do reverse way. We have this as the question and this is what we are supposed to get as the answer. So let's start here. Let's start with the taking the square root of that. Square root of a square is a, and of 16 it is 4 like we just discussed, and here it is square, minus here we can write b, and square root of 9 is 3. Let's write whole square. Done. Now what we need to do, one time addition, another time subtraction. You can change the order, answer is going to remain same, don't worry about that. So let's write the answer. So here a by 4 minus b by 3, that's 1. Another is a by 4 plus b by 3, bracket close. So one time addition, another time subtraction. So this is how we solve, this is how we factorize when we have two perfect squares and subtraction between them. Remember, if there is addition between them, we cannot factorize it, right? So if we don't, please don't bother about that, right? This is the special case. With the subtraction, we just follow the reverse identity and we can get the answer. Let's discuss few other identities. Now let's solve few application problem of the factorization. Here you have area with you and you want to find the length and breadth. So how to do that one? Let's start. Give possible expression for the length and breadth of each of the following rectangles in which their areas are given. So if this is the area, we need to find the length and breadth. Means we need to factorize it, right? So we know area of the rectangle, that is length by breadth. So if we factorize this one, we are going to get length and breadth. One could be length, another could be the breadth, right? So let's start with the factorization. So there are three terms and this is quadratic polynomial, so we can use middle term splitting. Let's start with that. So here we have 25 as the coefficient of a square, right? So we cannot directly do that, the factors of the constant. Here we need to multiply 25 with 12. So this is what we need to do first, product of these two numbers. So 25 into 12 will give you what? 300. If you multiply and check it, that you are getting 300 there. Now that being done, now we need to find the factors of 300. We are supposed to find the factors of 300. Now 3 digit is difficult to do generally because there could be so many n number of factors, right? And we add them and then we check that are we getting 35 or not. That's very difficult. Possibilities are many. That's the concern, right? Now suppose instead of 300, if we remove 1 0, we will be having 30 as the number. Now can we get the factors of 30? Right, factors of 30, because there are very less factors of 30. So I'm starting with factors of 30. So let's say 1 into 30s are, then 2 into 15s are, 3 into 10s are, 6 into 5s are. So that's it, right? Now what are we going to do? This is the beauty about the 0. You can put 0 anywhere and you can get your answer quickly, right? If you do 60 into 5, right, at a time you need to make sure that you get addition as 35 as well. That is also you need to keep in mind. 60 plus 5 will give you 65. So we need 35, not possible. Let's try to put 0 over here. That 50 plus 6, that's 56. So this factor is not possible. I'm trying to put 0 on both of the side and add them and check that am I getting 35 or not. So here 30 plus 10 will give you 40. No, we have 5 extra. Put 0 over here, that's 100 plus 3, 103. That's way far, right? Let's try with this one. Let's put 0 with 2 over here. 20 plus 15, we get 35. And 20 into 15 will be what? 300, right? That's what we want. So what are the choice of factors? That is 20 multiplied by 15. You can check it that 20 multiplied by 15 is equal to 300 and 20 plus 15, that is 35, right? So we are interested in these two numbers. If you multiply, you get 300. If you add them, you get 35, right? So let's replace it here. 25 a square minus, instead of 35, what are we going to write? 20 plus 15 into a plus 12. Done. Now let's multiply a with each of them one by one. So 25a square minus 20a minus 15a plus 12. Done. Now let's take the things common. 25 and 20, both of them are present in table of 5. So let's take 5 common, and here a square and a. So let's take a as the common as well. 5 5s are 25. So here 5a and here only minus 4. Let's write the same over here. So 5a minus 4. So 15 and 12, both of them are present in table of 3. So 3 here. Now what about this sign? We have discussed this already. Let's repeat one more time. Both numbers sign is being changed, right? Plus become minus and minus become plus. So in that case, you need to take the minus common out. So what's left over here? Let's take common first of all. 5a minus 4, and here 5a minus 3, right? This is the answer. This is the factorization. If you take this as the area, right, then anyone could be length and anyone could be breadth. Length multiplied by breadth, and let's say this is the area. So this is the application problem, right? We have this area and in the form of polynomial. If you factorize it, you get two factors, and area of the rectangle is also of the two quantity, that is length multiplied by breadth, two-dimensional figure. Now let's discuss one more question. Here we have 200 square plus 10x minus 1. So here also the case that we need to multiply constant with the coefficient of the x square. So that is 200. Now 200 it is. Like we did over here, we did not factorize 300, but we factorize 30. So same we are going to do over here. We are not going to find the factors of 200 because there could be so many, right? So we'll only find the factors of 20. So factors are, let's start, 1 into 20, then 2 into 10, then 4 into 5, right? These are the factors of 20. Now we need one extra 0, so you can start putting 0 on either of side and make sure that subtraction should be 10. So if we put over here 0, let's say 10, right? Here 10 and 20, and if you subtract 20 minus 10, you are going to get what? 10. Very simple, right? So I think this will be our choice of factors, right? So let's start, let's cross verify that 10 into 20 will give you 200, and 10, let's say 20 minus 10 will give you 10 only. That's what we want, right? So this is how we get our factors. So let's write the factors. 200 x square plus, here we will write 20 minus 10 into x minus 1. So 200x square, let's multiply this x's, one of them, 1 by 1. So 20x minus 10x minus 1. Very simple to do, right? We know very well. We'll make pair of these two terms and then these two terms, and whatever is the common, we'll take the common out. So let's take 20 x square and x, so we can take x as the common. Here what will be left? 10x, and here see the term itself has come out. In that case we need to replace with 1, so positive over here and 1, and here minus and minus, let's take minus 1 common, that is 10x plus 1, right? So if we take 10x plus 1 common, so what's left in this case? That is 20x, and what's left over here? That is minus 1. So these are the factors of this polynomial. Now this is the area of the rectangle. We should be having length and breadth, so you can say either of them as the length and one of them as the breadth. That will work out. Length and breadth can also work out, right? So the factorization of quadratic polynomial gives you two factors, right? As a result of it, we can say that that could be the area of the triangle as well. So this is how we find the length and breadth of the rectangle when area is given in the form of quadratic polynomial.